Hi everyone, it is Sridevi, Professor of Electronics and Communication Engineering Department. In this video lecture, we are going to learn about hazards and how to design a hazard-free circuit. Initially, we have to know what is hazard. On completion of this course, the learners can able to understand what is a hazard-free circuit and how to design the hazard-free circuit. First, hazards are some unwanted circuit transitions. That circuit transitions can cause some unwanted or undesirable effect inside the circuit. Because of this effect, the paths can exhibit some propagation delays. So, due to this propagation delay, the circuit's operation will be get delayed. So, hazards occurs in a combination circuit where they may cause some temporary false output value. So that false value is temporary. Afterwards, it will finally it will give the correct value. So because of that false output value in a particular duration time, there will be some delay of the circuit. Because this is called as hazards. Hazards are classified into different types. Basic hazard types are static 0 hazard and static 1 hazard. So in any change from 0 to 1 or 1 to 0, normally it will be occurs. So if one output is 0 and the circuit will produce an output as 1 for temporary time, then it is a hazard circuit. So the type of implementation may cause in the output to go to 0 when it should remain a 1. This is called a static 1 hazard. See the diagram. In this diagram, one pulse is there. In this pulse, 1 is the value top that is mentioned the top, and low we have mentioned as 0. The output may momentarily go to 1 when it should remain 0. This is referred as static 0 hazard. That is here starts from 0 but it maintains 1. So this is called as static 0 hazard. So there is also another one type of hazard that is also called as dynamic hazard. This causes the output to change to 2 to 3 minutes when it changes from 1 to 0 or 0 to 1. This is called as dynamic hazards. And we have to know what is essential hazard. Essential hazard is a hazard which produces the results of the effects as a single input variable change reaching one feedback path before another feedback path. So the circuit should have more than one feedback path. So when the correct output occurs through one feedback path but another one feedback path, the circuit can get output. That output may be false. That is called as essential hazard. So this type of hazards we can see in the hazard circuits. So the delay in the inverters, here we are having one circuit. In the circuit we are having 3 AND gates and 1 OR gates. So 3 AND gates are connected to one OR gate and the OR gate produces the output. So we are having one inverter. The inverter in this circuit changes the output of the gate 2 from 1 to 0 before the output of the gate 1 changes to 1. This is the output of gate 3 goes to 0 for the short interval of time because both the inputs of the gate 3 are momentarily equal to 0. Therefore, the circuit undergoes through the condition of static 1 hazard. So, if we want to make a static 0 hazard, same thing, but the inverter position can be changed. This is called a static 0 hazard. So, in case of asynchronous logic circuit, to make a hazard-free circuit, the circuit should be simply our produced in such a way that the same repeated components should be avoided. So, a circuit with hazard with NAND implementation and a circuit with hazard with NOR implementation can be available. So, initial setting when all the inputs equal to 1, the circuit gives 1 as output. When the output changes from 0, it produces 0 as output. So the asynchronous sequential circuits, in this asynchronous sequential logic circuits, we can design the hazard-free circuit. So here we can get the hazard-free circuit to give the output as an undelayed one. Without delay, we can get the output for a hazard-free circuit. So this is the way to produce the hazard-free circuit. So first, why hazards should be avoided in this circuit? To produce the output in a fast way or speed way, it should be avoided. That's all about this hazard free circuits.